Alright, so in this lesson, we'll be learning about what we call special products of algebraic expressions. So what we will be doing, alright, is actually simply to be using these special products to expand algebraic expressions, okay? And of course, the algebraic expressions will have to fit in this special formula, okay, using special products, okay. So you can think of this special product of algebraic expression as what we call a shortcut to expanding. A shortcut to expanding. Okay. So let's take a look at what these special products are. So we have three special products that you will have to remember. Now the first one is if I have a plus b and the whole thing square, okay, what you will get, okay, if I expand this, will simply be a square plus 2ab plus b square. Okay, so I repeat if you expand a plus b the whole thing square, okay, you don't have to do the multiplication frame. You can straight away write it as a square plus 2ab plus b square. Now if I expand a minus b the whole thing square, okay, I'll get almost the same thing except that instead of a square plus 2ab, I will have a square minus 2ab plus b square. And if I expand a plus b, a minus b, I will simply get a square minus b square. So these are your three special products of algebraic expressions. Again, shortcut. So as long as my expansion fulfills this criteria, something plus something the whole thing square, something minus something the whole thing square, something plus something multiplied by something minus something, I can easily use this special product to expand. Okay, so these are what we call shortcuts. So I repeat again, if I expand a plus b the whole thing square, I'll get a square plus 2ab plus b square. If I expand a minus b the whole thing square, I will get a square minus 2ab plus b square. And if I expand a plus b, a minus b, I'll get a square minus b square. Alright, so if we in the next part, we will take a look at equations so that we can understand better on how to use these special products to expand. So let's take a look at level 1. Okay, in this question we have expand y plus 6 square. Okay, so you realize that this fulfills the criteria of the very first one. Okay, because if you put this in bracket, you can say that y is a and 6 is b, so a plus b square. Okay, so what happens is if I expand this, I'll get a square plus 2ab plus b square. Now, because we are going to replace a and b with y and 6 respectively, so what we will do is we'll put this form itself, this bracket square plus 2 bracket bracket plus bracket square. So this is to represent your a square plus 2ab plus b square itself. Okay, so instead of putting a and b inside the brackets, I have y plus 6 square, so I'll put y in the first bracket and y in the second bracket. And for b, because b is 6, I'll put 6 in the first bracket and 6 in the second bracket. And then I'll write down the final answer. I'll have y plus 6 square. If I expand them, I'll have y square plus 12y, and 6 square is simply 36. So you realize that it's quite a simple shortcut because you don't have to draw a multiplication frame itself. You don't have to simplify. It's simplified already. It's quite straightforward. Okay, so let's take a look at the second question. Now, if I have n minus 8 square, so n minus 8 square, you realize, okay, we have n minus 8 square. So n minus 8 square will fulfill this form here, a minus b square. Okay, a minus b square. Okay, so again, since it fulfills a minus b square, okay, so what we want to do is we will want to change this to put we will use this expansion, so we put a minus b. So let's rewrite back the whole expansion, the formula. A minus b square is simply a square minus 2ab plus b square. Okay, so you realize that over here, Okay, I've already put in the brackets for you. So this is your a minus b square. So a minus b square is simply a square minus 2ab plus b square. So in this case, your a is n and your a is n. Okay, now you realize that I don't put in the b as a negative b. I'll just put b as a number itself. So 8 and 8. So I don't have to put the negative sign itself for this expansion. So when you're using this shortcut method, these special products, okay, the negative sign has already been accounted for in this negative part here. Okay, so let's expand them. I'll have n square minus 2 times 8, so 16n, and 8 square is simply 64, and I'm done. Okay, so quite straightforward. Okay, so let's take a look at the third one. So I have q minus 6 and q plus 6. Now you realize that q minus 6 and q plus 6 will follow this form a minus b, a plus b. Okay, although it's reverse, okay, your a minus b and a plus b, okay, is actually the same as a plus b, a minus b. Sorry, a minus b, a plus b. Okay, so this, okay, can also be written as a minus b, a plus b. It's okay. It's the same thing. Okay, either way, you'll still get a square minus b square. So if I expand q minus 6, q plus 6, okay, I should get something square minus something square. So inside the brackets, okay, because I have a minus b, a plus b equals to a square minus b square. Okay, so your a is q, your b is 6. So just put in q, it's 6 here. So q square is q square, and 6 square is 36. So q square minus 36. Yeah, so that's how you expand it. Okay, so in exams, if let's say it comes in this form in a plus b square, you expand them, you get a square plus 2ab plus b square. If it's a minus b square, then it will be a minus a square minus 2ab plus b square. If it's a plus b, a minus b, or a minus b, a plus b, doesn't matter the order, it will be a square minus b square. All right, so I hope this is clear to you. Okay, let's take a look at more examples. Okay, so now I have 40 plus 1 square. So 40 plus 1 square, okay, the rest is something plus something square. So it fulfills this criteria over here. Something plus something square. Okay, so let's rewrite back the formula first before we do anything about it. Okay, so the formula that we have over here, okay, is simply a plus b the whole thing square is equals to a square plus 2ab plus b square. Okay, so if I was to expand 40 plus 1 the whole thing square, what I will do is I'll write down the question first. 40 plus 1 the whole thing square. So I will need my brackets. Okay, so a square, so bracket square plus 2 bracket bracket, so 2ab plus b square, so bracket square. And then I will replace the brackets, the a, with whatever that's inside this bracket here. So your a is 40 and your b is 1. So 40, 40, 1, 1. So expanding them, I will have 40 square, which is 16t square. So you must square both the number and the alphabet, plus 2 times 40 is 80. 80 times 1 is 80. So 80 plus 1 square, so plus 1. Okay, and I am done over here. Okay, so take a while for take a few seconds to take a look at this. Okay, now let's take a look at the second one. So the second one, I have 7p minus 2 square. So 7p minus 2 square will fulfill the form of a minus b the whole thing square. So let's write down the formula again. Okay, so if I have a minus b the whole thing square, okay, if I expand it, I will have a square minus 2ab plus b square. All right, so when I expand this, what happens is, okay, I will have, okay, so we will rewrite back everything again. So we will write down 7p minus 2 the whole thing square is equals to, so a square, so write down in brackets a square minus 2 AB plus B square, and then we replace your A and B's, your brackets, with whatever that's inside the equation itself. So A is 7p, so write down 7p and 7p. And then your B is 2, so write down 2 and 2. So expanding this, I will have 7p square, so 49 p square. How do I get 49? 7 square is 49, p square is p square. Minus, so 2 times 7p is 14p. 14p times 2 is 28p. And 2 square is simply 4. Alright? So that's how you expand your 7p minus 2 the whole thing square without using a multiplication frame itself. Then let's take a look at the last one. Okay, 11u plus 5v, 11u minus 5v. So you realize that this is simply your a plus b and a minus b. Both the first and second term of the first bracket is the same as the first and second term of the second bracket. Okay, so let's rewrite back the formula first. So I have a plus b, a minus b is equals to a square minus b square. Okay, so same thing, we will write down in terms of brackets. So I have 11u plus 5v, 11u minus 5v. Okay, so if I expand this, okay, I will have a square, so bracket square, minus b square minus another bracket square. So my a in this case is 11u, my v is 5v, so 11u and 5v. So 11u, expanding this bracket, 11u square, 11 square is 121, u square is simply u square, minus 5v square is simply 25v square. And that's it. Okay, so a very simple way to expand your algebraic expression as long as it fulfill the conditions, or rather the form that is given to you. Okay, as long as you fulfill the a plus b the whole thing square, a minus b the whole thing square, a plus b, a minus b, then I don't have to use a multiplication frame. I can simply use this as what we call a shortcut itself. Okay, so I will end off this video here. In the next video, we will take a look at further examples, more complicated examples on how to apply this formula itself to more questions. All right.